Okay, so officially we are going to start our routing topics from here. Krista, if you can tell me about what is protocols and what they are used for.
The protocols are a list of standard that is used by technology.
Yeah, okay, no problem. The same, yes, you have a good understanding. A routing, as it's written, a routing protocol specify how routers communicate with each other. Okay, this is the first thing. To distribute information that enables to select routes between nodes on a computer network. So the same idea, like we have multiple routers connected. And we have different subnets, like 10 network is here, and we have like 172 subnet network is here. If you will do the same thing in the switches, you connect this subnet and this subnet, it's not going to communicate. So you need these routers which will be running a protocols, kind of routing protocols that will enable you to communicate this network with this network. Not only this will distribute information, whatever, maybe the servers here, wireless LAN controllers, whatever the information here. If you want to distribute this one, you will have to have these kind of protocols. These will enable these features for you. And what those protocols are, I have mentioned here. These are the RIP is not mentioned here, by the way. I think it's pretty much gone. RIP. Yeah, it's here. We have RIP. This is very basic, and we are going to do the lab for that as well. So you have better idea how the protocol works, what is going behind the scene. So this is one of the protocol. Then we have this OSPF we talked about, EIGRP. So these are all protocols, but I'm just pointing out the famous, the well-known, and the BGP that we talked earlier as well. The BGP, it's I think not mentioned here, but we have the BGP as well. Okay, so these are the routing protocols that will basically help us communicate with each other. Then we have another thing, as I talked, administrative distance. And what are those AD and matrix? If I give you, yep, this one. So what is administrative distance? The administrative distance is a number used to rate the trustworthiness of the routing information received from the routing neighbor. It is used when a router must choose between routes learned using different routing protocols. Each routing protocol has a default AD value. I know this is mouthful, and it will be very confusing at this time of point, but just remember, this is the believability of your routing protocols. If you are getting multiple routes, okay, in our router, let's say if I give you example, I have these examples in subsequent slides, but just for the clarification, as it is mentioned here, different routing protocols. This is the recipe. And what does it mean by different routing protocols?
So, Kamran,
Yep.
coming back to those gray areas of thinking around.
Okay.
So this type of protocol, the decisions are made probably right in the beginning of when somebody's implementing infrastructure, right?
Okay. Yep.
When let's say it's a school and we have to connect with different branches of our school, and I think based on that we would create some type of some of the best practices type of protocols. I guess that's what it is. And then second is like why do we need specific protocols for specific needs, right?
Yeah. Okay. Actually, really, Danish, sorry for interruption, but really, I got the idea. But you know, yep, we can go a lot in detail. Like RAPE is very basic protocol, and I know this is very small enterprise where we have small organization there we use, and these ISIS basically used in a service provider because it has more features and capable of doing so many things.
I see, and I think that's what I wanted to ask. That
Yep,
when
exactly.
it comes to understanding like why do we use these, who
Yes.
uses this protocol for what reason, is I think the confusion.
So the Danish, the basic idea is, as I said, the basic idea. We have multiple subnets here, different subnet, this subnet, and this different subnet. We know that switches are not capable of doing these things. For different subnets, we cannot communicate with different subnets. If we have different subnet here and different here, on switching environment, we cannot do it. So that's why we need routers. And then routers should have kind of protocols that will be running on these all routers. So
in that we also have specialized routers to do different things
yes,
because of the features it comes with.
yes.
Okay, Christelle, is it clear? You understand why we need these protocols, right?
Yes.
Okay, and then these routers have these protocols have multiple routing protocols, flavors of routing protocols. As I said, RAPE, ISIS, SPF, EIGRP, and I also, I cleared this thing in the earlier slide as well. The OSPF and EIGRP, they do the same thing almost. But the problem is EIGRP Cisco proprietary, while OSPF open standard. That is the reason service provider are using OSPF to make the communication. We have multiple vendors, like Cisco is connected with Juniper router. We have Cisco router, we have Juniper routers, and they want to exchange the information. If we use EIGRP here, it will fail. So that is the reason IEEE, they came up with the idea of having an independent protocol, which is OSPF. So if we have Cisco router here, Juniper here, we will run OSPF here in between. So now our information can pass through it. Then these RIP has some kind of issues. If I give you here right away, after 15 routers, if you connect 15 routers, I'm not gonna draw all 15 routers here, but let's say this is first router, and then we have multiple routers and 15 routers here. And let's say this is the 16th router here. And we have host machine here, and we have a host machine here. And this host machine, if you want to communicate, this host machine, RIP will fail here. Because RIP works on hop count, which means, you remember we talked about tracer command, and we talked about TTL. If it becomes 0, it means there is a loop and it cannot proceed. So almost like same concept we have in a RIP. RIP can go to the 15th routers only. It can hop around 15 routers only. For example, this whole network is being used under RIP, and this wants to communicate. It will come here 1, 2, 3, 4, 5, 6, and all the way till 15. Now RIP knows that after 15, I'm gonna die. So this information will not go across.
Now, can it be changed later on? If somebody, let's say an engineer like me, who let's say are too new to this stuff, and I just learned about RIP, I implemented that, and tomorrow now we got in a deadlock. What happens then?
Basically, the communication will not happen. But the another important part is, like, these administrative distance can be changed. Let's suppose if I give you example just for the 2 or 3 routers, this host or machine wants to communicate with this host here. I'm just giving you the idea why means administrative distance, which I'm talking about, not AD, but the metric. The metric is hop count. By the way, it is too early to discuss here, but no problem.
You know, you don't have to go in details. Just like
Okay.
what we're discussing right now.
I'm just giving you overview since this question is asked, so I want to clear here.
Mm-hmm.
And we have some other routers here. And let's suppose this is connected here in a LAN, and this device on the same LAN, and this connected with this switch, let's say here, and this is host machine A, and this is B. And let's say this is whole architecture is using RIP protocol. As you can see, we have multiple paths in between. One path to reach for this host to reach this one, it can either go through this one, sorry. It can go through this way. This is the first, and it can go through this way as well. This is the second part. So network, as a network engineer, the hop count to reach through this is less. Okay, so RIP will prefer this one because it is like 1, 2, 3, and I forgot to add another one. Let's say this one. So to reach this destination, it has to hop around how many routers? 1, 2, 3, 4, 5. These are 5 routers here. And to reach this same destination, I'm talking about the same destination. We have same destination here. To reach for this host machine to reach this destination, it has to go through 1, 2, 3 hops. So RIP will prefer this one. But we have to do kind of things. This is what is known as traffic engineering. And what traffic engineering is, I don't want to prefer this path. This path, I don't want to prefer. So what is the remedy? So remedy is the network administrator will come here and he will tell to this router, you are 16 hops away.
I see, like manually you put that in there.
Yep, manually you will put that this metric. So when I want to reach, now I have 2 ways to reach, but now I have manually put 16 hops. It means it is like 16, 17, 18 hop away now. Now this is not 3, but 18 hop away. And this one is still 5. Although it has 3 routers, but with the help of metric, I am able to achieve my task going through this path. Got it?
Yep, that makes sense. And the idea at the end is this, that, you know, when people look at it, when someone's so new to this stuff, this is why we need this different type of protocols for different reasons. And somebody has to go in there, configure it. Basically, a router will not come with stuff like that, right? It's like when you get in, you have to do everything in there. You have to add all these configuration in there, right? Come on.
Yes, exactly. And you gave me another idea, so I can describe here as well since we are here. But how about the ISP? ISP have tons and tons of router in its domain. So do you think that they're gonna use RIP protocol there? Never ever, because RIP never goes beyond 15 routers.
Mm-hmm.
And we have, like, let's say we have here around 100 routers in the ISP. So opposed to RIP, we have another solutions or the flavors like ISIS, OSPF, EIGRP. Okay. So this is why we are gonna use EIGRP over RIP. So that's why we have multiple routing protocols.
Great, thank you. That was pretty clear explanation.